Hello, here we start chapter 6. 6.1 is talking about indefinite integration. Okay, this will be an introduction to indefinite integration. I'll give you a couple of examples. Let's say, by the way, integration is calculating area. So let's say I want you to integrate these functions, and also you know that integration is the opposite for derivation. Alright, let's start with these three examples. So whenever you have x to the power of n integrated, just add, here do it, x to the power of n plus 1 over n plus 1, the same power here will be divided, plus some constant number, because if you differentiate it, it will be like it's reversible. Integration and differentiation and integration are reversible undoing operations. So here you have x to the power of 6, so add here 1, it will be x to the power of 7 over, divide by the same power here, over 7 plus some constant number c. Here, to make it simpler, like put 1 over x squared can be changed into x to the power of negative 2 dx, because I just brought the x up. So now add on negative 2 plus 1, it will be negative 1, and subtract and divide by negative 1. X divided by negative 1 is just negative x to the power of negative 1 plus c, or you can write this one negative 1 over x, this power you can do it like a denominator, so it can be negative 1 over x plus c. Again, here to make it simpler, instead of this radical you can write x to the power of half dx. So add 1, if you add 1, it will be x to the power of 3 over 2 divided by 3 over 2 plus c. When you write this one into a proper way, it will be reciprocal, that means 2 over 3 x to the power of 3 over 2 plus c. So these are our three different answers. I'll give you more examples. You know this e to the power of, let's say, mx dx. So the integration is with respect to x. So always once you are having this type of integration, you're going to do e to the power of mx. Don't change anything in the power here, just divide by the coefficient of x, which is divided by n. So plus here, of course. So here the same thing will happen, e to the power of 2x, nothing will be changed on this power, to x divided by 2 plus c, or you can write half e to the power of 2x plus c. Both are right answers, just written in different ways. Okay. One more example here. Let's say I have differentiation of 4 dx. So if you're going to differentiate a constant number, just add on it an x, for x plus c. Okay. Let's say I have an integration of 2x squared minus 4x to the power of 6 dx. Now you can distribute this integration. It can be 2x squared dx minus integration of 4x to the power of 6 dx. So here what I did is I just distributed this integration for both terms. Now you can take out the 2 as a constant if you want. So here you can have like this, and also you can do the same thing, take out before. Don't change the sign, it's just because it's a constant, you can take it out. X to the power of 6 dx. And even if you didn't take it out, nothing will change. It will be the same answer even if you leave it inside the integration. So now what would be the integration of x squared? Add on the exponent 1, so it will be 2 plus 1, it will be x cubed divided by 3 plus c minus, don't forget that this will be in a bracket, minus 4, and here x to the power of 7 over 7 plus c. Same thing here on the 6, I'm going to add a 1. So constant plus constant will be just a constant number that I have no idea about it. Here I can rearrange it and write it in a better way. You can have 2 over 3 x cubed minus 4 over 7 x to the power of 7 plus c. This can be your right sum or the integration. Okay, I'll add for you one more example. Let's say you want to integrate this sum, which is 2x minus 4x cubed plus 1 dx. So again, you can distribute the integration. I can distribute the integration this way, and I can start by integrating. Here, let's say that I want to leave the 2 here, or I want to take it out. Same ways, you'll have the same answer as I told you. What if I left it? It will be 2x. Here it's the power of 1, so 1 plus 1, it will be 2 to the power of 2 over 2. And this will be cancelled. Even if you take it out, if you already took it out, it will be the same thing here. So there is no difference to take the constant out or to leave it. The coefficient here, you can take it out as a constant, or you can leave it, it's up to you. Plus c, how about here, it will be negative 4 x to the power of 4 over 4, because on these exponents you are adding 1, plus c, plus here you have just a constant, so the integration here will be x plus c. So here, by the way, you can write just one c at the end, or you can write it more than once, but constant plus constant plus constant will be just one. You can call them constant 1, constant 2, constant 3. At the end it will be just one constant. Here you can simplify. You'll be left with x squared minus x to the power of 4 plus x plus c. So this will be my sum. I'll give you 2 questions that I want you to integrate by yourself. So the first one is saying integration of 10x to the power of 4 plus 5 over x squared dx. Second one, integration of 7x squared minus 3x plus 2 dx.